The next section we're going to get into ties into concepts of three-dimensional graphing and taking what you've learned with distance formula, midpoints, and applying them to three dimensions. So when we graph in three dimensions, we've got an x, y, and z axis. And for beginners, we're going to start with the x-axis as being defined as forward and backwards, the y as being left and right, and z is being up and down. Now, before I get too far on this, when we're working with three dimensions, the other piece we have to take into account is perspective. If I look at an XY chart from behind the graph, it's still X is horizontal and Y is vertical. But when I'm in three dimensions, I can go to the top, I can go diagonally. So which direction is my X, which direction is my Y, which direction is my Z? So we need to see on our different graphs, where are the X, Y, and Z axes oriented, and then we can know where to go. Specifically here, when I say X direction is being forward and backwards, this is labeled as my x-axis. So going forward and backwards, here's my x-axis. Here y is labeled as left and right. So that's why I'm going left and right here, and then z is up and down. However, let me give you another example. Here's something that's graphed in three dimensions. These are the points that are in three dimensions, but notice how these graphs are labeled. This one is labeled as the x-axis as being left or right, the y-axis is being forward and backwards, and the z-axis is being up and down. So it really depends on how your axes are labeled as you define forward, backwards, left, right, up, or down. So just be aware that depending which textbook you look at and what reference you're using or what situation you're given, your x, y, and z axis could be defined differently based off of what perspective you are looking from. So here's one example of something that's in three dimensions. When you're in three dimensions, you go in the direction of two of the axes and then find the third axis. So right here, for this point here, Q, at -5, -5, 7, here we've got the x point, the y point, and the z point. That is always the case. Our ordered pair, instead of just being x and y now, is x, y, z. So first thing I do is I look for my x-axis, which is the first point, and I go -5 units in the direction of that axis. So here's -5. The second value is the y value, which is -5. So I find my y-axis here, and -5 is in this direction. So I start here at this point I'm already at, and then I come out -5 units down. And then finally this z point is the last point, and it's going straight up. So I go to the -7, right, or the +7, and that's where my units are, 7 units out. Now you can see I don't just plop it right up here because I had this movement outwards. So I've got to include that movement outward as I graph my points. So as you can see here, this picture in three dimensions is floating out here. I just can't line it up here with 7 on the z-axis because that would indicate 0 movement outward. But I actually have -5 units outward in this case. So that's why I'm a little bit further beneath that 7 on the z-axis. Here's another example of the point 2, 3, 5. This one you can see the x-axis is coming out as opposed to the y-axis. And this is the way you're going to see it on your sheet. Here we go down 2 units, which here it's +2. Then we're going over 3 units, and then finally up 5 units. So the point 2, 3, 5 is sitting out in space, sort of upward in this first quadrant area. So I want to draw the point 2, 3, -4. And for what we'll be doing, I'm really not looking at you to be an artist with this, but to get the general idea of where the point is going to be. So we've got the x, y, z coordinate. So I'm going to draw the point 2, 3, 4. So the first thing I'm going to do is I'm going to come out 2 units on the x-axis. I'm going to go over 3 units on the y-axis. So my first part then is drawing like the top of this box here, which is 2 units out and 3 units over. Now you can see right here with the y-axis, I did not come straight down. I've got to go slightly on a diagonal. You might want to imagine that there are parallel lines going through each one of these points. And that's the line that I'm going to follow down. So here, imagine that there is a line that is parallel to my x-axis that I draw down in order to get to that point. Here, I come out 2 units, then go horizontally until I would intersect that parallel line. The last piece then is 4 units down. So I need to go down 4 units. So 1, 2, 3, 4. And somewhere right about there is going to be the point 2, 3, negative 4. Once again, it's not going to just be lined up perfectly with this negative 4 point right there on the z-axis, because that would indicate that there was no movement in the x direction coming outward. If this were the point 0, 3, negative 4, I could just go 3 over negative 4 down and then say my point is perfectly lined up. But the fact that I've got those 2 units coming outward means that I've sort of pulled this point away from this negative 4 line. So I'm a little bit further beyond that. If I draw the point negative 5, negative 2, 3, once again, that's x, y, z. And if I go negative 5, 1, 2, 3, 4, 5, I'll head negative 5 backwards there. Negative 2 is going to be 2 over. So once again, imagine there's this parallel line going to where that negative 5 is. So we'd come out this way and then intersect that parallel line. And then finally, we would go 3 units up. So 1, 2, 3. So somewhere up there is going to be my point negative 5, negative 2, 3. So once again, I'm not looking for a perfect picture. What you're going to have most of the time is if I give you a drawing with the axes labeled, can you tell me what the point is? I'm not going to have you draw out the point in space like that, just because it's very hard to draw in 3 dimensions on a 2-dimensional sheet of paper.